For this class period, we're going to learn why we have been talking about limits and how this all connects back to what we did on the first day of class. We're not actually going to talk about this in the video. Today, I'm just going to define some interesting new thing called a derivative. You're not necessarily going to understand what it tells us until we get to class, but in class, we're going to understand why the derivative is so important and what exactly it tells us about our function. So for now, we're just going to keep this interesting looking limit. So I'm going to define the derivative to be denoted like this, f with a little, what do you call that, like an apostrophe. And we read this as f prime. So that's how that's read, f prime of, so yeah, f prime of a. A is the thing in there. And we have this other notation. I'll read that in a second. But we define the derivative. We write it to be f prime of a, and we define it to be this limit here. A is going to be a number that we plug in. We have this other notation over here. We read this as df over dx. F is our function, x is our variable, and then a down here is the number that we're plugging in. So two different notations. So let's just like practice what this is, because this might look a little weird at first. And once again, you might be like, well, why are we doing this? The answer to why are we doing this and what does this tell us, wait for class on that. We'll definitely talk about that in class. But how do we compute this? Let's just do some computations here. So for this first one, let's compute f prime of 9, where f of x is square root of x. So in this case, our a value, the number that we're plugging in, is 9. And so we can just rewrite this definition that I have up here. So f prime of 9 from this definition, I'm just going to replace the a's with 9 is the limit as x approaches 9 of f of x minus f of 9 over x minus 9. Okay, cool. Now we need to replace f of x in here. F of x in this problem is square root of x. So we have the limit as x approaches 9 root x minus f of 9, if I plug 9 into square root of x, will be square root of 9, which is 3, over x minus 9. Okay, so now we have set this limit up. Now we just have to compute a limit algebraically. So now we've boiled that down to a problem we could have done for the last test. So if we plug 9 in here, we're going to get 0 over 0. So we need to simplify. In all of these examples, you're going to have to simplify, just an FYI. When we've got those square roots, the way to simplify is multiplying by the conjugate. You should just do this work on your own. You don't really have to watch me do it. Hopefully you can do it on your own at this point. So we're going to get a limit as x approaches 9. We'll have x minus 9 in the numerator. We have our x minus 9 times root x plus 3 in the denominator. The x minus 9's cancel out. We're going to be left with a 1 in the numerator. When we plug in 9, we're going to have 1 over 3 plus 3, which is 1/6. So 1/6 is the derivative of this function at 9. Well, we don't know what that tells us yet. So we've got to wait for our class to understand what this tells us about our function, but it's going to tell us something important. Okay, so we're just going to do 2 more examples. So df over dx at x equals 4. So this is the same thing as saying find f prime of 4, just 2 different notations. We're going to get a lot of different notations here, so we just need to be careful with all our notations. And I really didn't need to write all of this extra stuff because I already told you that here. We can say that f prime of 4 is the limit as x approaches 4 of f of x minus f of 4 over x minus 4. It's always good to go ahead and just rewrite that definition with the 4's plugged in. Okay, so now we're going to have a limit as x approaches 4. This is my f of x. And f of 4, I'm going to have, if I plug 4 into that, I'm going to get 16 plus 8 minus 1. So it's going to give me 23. So I'm going to have minus 23 all over x minus 4. If I plug 4 into this, I get 0 over 0. So I need to simplify. You should try that simplification and then come back and check you got the same thing as me. So I'm going to get a limit as x approaches 4. I'm going to combine these two guys. I have x squared plus 2x minus 24 over x minus 4. Factoring this looks like a good idea. So if I factor that numerator, I'm going to have x minus 4. I need 2 numbers that multiply to give me negative 24 and add to 2. So that would be 4 and 6. and the 4 will be negative and the 6 will be positive, so that this term is positive. And we'll have x minus 4. The x minus 4's cancel out. When we plug 4 into that, we get 10 out. Once again, 10 is going to tell us something about this function at x equals 4. We just have to wait for class to figure out what that tells us. Now, why don't you see if you can do this last one on your own? Otherwise, I'll go ahead and keep working it. So f prime of negative 1 will be the limit as x approaches negative 1 of f of x minus f of negative 1 over x minus negative 1. Make sure you have those double negatives there because it's x minus a is negative. So yeah, this is our a value here. So we get a limit as x approaches negative 1. My function is 3x. F of negative 1 will be negative 3. So I'm going to have a minus a negative 3 over x plus 1. So once again, if I plug negative 1 in here, I get 0 out of 0, or 0 over 0. So I have to simplify. So I get a limit as x approaches negative 1, 3x plus 3. Well, let's go ahead. We can pull a 3 out. This is 3x plus 3. We can pull a 3 out. So left with x plus 1, x plus 1. This cancel out. We're just left with 3. We don't have anywhere to plug the x in, so our answer is just 3. Okay, so it's the derivative of this function at x equals negative 1, and we have to wait for class to figure out what that means. So hopefully these limits were okay.